Welcome. In this video, we'll explore how the Melectric Gateway bridges the gap between our wireless sensors and industrial control systems. First, let's get familiar with the hardware of the gateway. Here we see the physical setup, the Melectric BLE Flange torque sensor, our Melectric Gateway, and the laptop displaying the configuration interface. Let's take a closer look at the gateway unit itself. On this side, we have the SMA connector for the external antenna, which provides the wireless communication link. And right beside it is the slot for the microSD card used for onboard data logging. Turning the gateway, we see the main green terminal block. This is where you connect the power supply and wire up the physical outputs like analog, CAN bus, and RS485 Modbus. Also located near the terminals are two status LEDs. These lights indicate connection status and different status codes. The gateway's primary function is to connect wirelessly to the Melectric Torque Flange and offer its data on multiple sources. Now we take a look at the configuration interface, which is easily accessible simply by connecting to the gateway's Wi-Fi. We can see the current torque, reading, RPM, temperature, and the sensor's battery level. The status indicators show the gateway is connected and the flange is communicating via BLE. The gateway has an internal clock for data logging. We can easily sync it with our computer's time by clicking the Sync Time button. On the left, we have configuration options for the different outputs and logging features. Analog, CAN bus, Modbus RTU, and SD card logging. Each module can be turned on or off, and detailed settings accessed via the Settings button. Let's quickly look at the analog output settings. Clicking Settings opens the configuration window. Here you define the full torque range that corresponds to the analog output signal and select the output mode like 0 to 5 volts, 4 to 20 milliamps, or as currently set, 0 to 20 milliamps. We won't change anything, so let's hit Cancel. Next, the CAN bus settings. Here we can set the specific CAN message ID the gateway will use, the baud rate for the CAN network, and the cyclical rate, which is how frequently the data is broadcast on the bus. Let's change the cyclical rate from 100 Hz to 1000 Hz. The gateway can log sensor data directly to an SD card. In the SD card settings, we can specify a file name prefix. We can select the delimiter for the data file. Let's choose semicolon and set the logging frequency. Let's pick 50 Hz. Now we'll try to save this. Besides configuring the outputs, we can also adjust settings on the BLE flange sensor itself using this settings cog icon in the top right of the flange section. In the sensor settings, we can select the sensor sampling rate, perform a tare function to zero the current torque reading, and reverse the torque direction if the sensor orientation requires it. This demonstration covered the hardware and software configuration of the Melectric Gateway system, showing its capability to integrate wireless BLE flange data. To learn more or discuss your project, please visit melectricsystems.com